Oh, good. Okay. For the rest of the time, I want to talk about Prolog. Yeah, so these are some notes that were originally put together by a colleague of mine, Bill Wilson, who's recently retired. And but while he used to teach this course many years ago, or a similar course, and one thing he did build up was this Prolog dictionary. You'll see links to the Prolog dictionary throughout this, and so he's got a dictionary of a lot of different things that people need to look up in Prolog, and that's a very valuable resource, actually. Now, Prolog was basically invented by these two guys, Robert Kowalski and Alan Kolmar. I'm not sure. I'm never sure how to pronounce his name, but Kolmar, I think. Sorry. And so what's different between Prolog and imperative language? So like I say, maybe not all of you, but most of you have probably seen languages like Python or C that are written like a recipe book. So you've got the list of ingredients at the top, and then you've got instructions for what to do. So you have int x comma y, and then you say x equals y plus 1 or whatever. So that's probably what you're used to. Now, Prolog is a little bit different. So this is Ivan Bratko, who wrote the textbook. He's at the University of Ljubljana. Now, what happens with Prolog is you put in facts. It's a bit like a sort of database or something like this. You have a list of facts, and then it tries to search and deduce other facts from those facts. So let me just try to run Prolog. Okay, so if you log into your CSE account, which is what I've done here, you just type Prolog and SWI Prolog will come up. If you want to run it on your own laptop, there's links to the SWI Prolog page, and then you can download it. Someone was asking in the break whether there's a graphical IDE. I think there is one available for some platforms. So you can have a look at that. Also, yeah, I mean, I'm running a Mac here, so if I want to run it locally, I installed it through Mac ports. I just did sudo port install SWI Prolog, and if you're running Linux, actually, let's have a show of hands. Who primarily uses Windows? Who uses a Mac? Who uses Linux? Who uses something else? Interesting. Okay, so a lot of those Linux things you can get by doing apt-get or something like that. So you can sometimes you can just install it from the command line, or you can download it from the page. If I want to run it here on the map, instead of Prolog, I have to type SWIPL, SWI Prolog, but it runs exactly the same way. So we have a program that consists of a bunch of facts and a bunch of rules. In these notes here, we talk about family relationships. So this is the theme that's picked up on in the labs. So if you do the labs, there'll be facts like Henry is the parent of Suzanne, and Henry is also the parent of Lucy, and Suzanne is female, and then from those facts you deduce the fact that Suzanne is the sister of Lucy. You know, these family relationships. So that's the theme that'll be picked up on in the labs. But just for this demonstration here, we have a slightly different theme. And again, yeah, this my colleague came up with this, and I have to confess, this is very, like the way those people who write Hollywood musicals sometimes write Hollywood musicals about people writing Hollywood musicals, and the same way academics, when they need to think of an example, sometimes they think of the example of academics teaching courses because that's what they're familiar with. So that's actually what we have for this first example. So so the facts here consists of a list of courses and who's teaching each course, right? And this is in a file. So, and this file is just called facts number 3, and there's the list of facts there. So if you're, so when you get into the lab, you're going to have to be editing a text file, so you've got to decide on your favorite text editor. So I use Emacs, but some of you may use other things, TextEdit or Vi or whatever. So you kind of edit a text file in one window usually, and then you run your program in another window from the command line. So this is this list of facts, and these are, of course, the names of famous AI people or programming people. So it says that Turing is lecturing the course 9020, COD is lecturing 9311, and so on. And then there's facts that say who's studying those courses and what year they're in, right? Now, if we want to load these facts, we just type Prolog -s and then the name of the file. And it comes up and it says this file was compiled in 0 seconds and into 4,000 bytes. So in other words, there's no syntax. If there's a syntax error in the file, then it'll warn you about it at this stage. But because it says this, that means there's no syntax errors. And then the facts are in there, so now we try to probe those facts. So one simple way to do that is just to test individual facts. So is it true that Turing is lecturing 9020? So I just type this and a full stop, and it comes back and says true. That means yes, Turing is lecturing 9020. If I ask whether Turing is lecturing 9120, it says false. And so on, right? Is luring, you know, whatever. Anything that's not in the facts that are not there come back as false. Now, you exhaust the fun of that pretty quickly, but then it becomes more exciting when you try to put a variable in there. So if I put an x in here, this is asking which course is Turing lecturing. And it comes back and says x equals 9020. Now the reason, because it's a capital letter, that's why it knows that it's a variable. So it looks for some x for which it's true that lectures Turing, comma, x. And the answer is 9020. Now, some people are lecturing more than one course, so I think COD is lecturing 2 different courses. So if I ask lectures COD x, now notice the difference in syntax here. So when I asked lectures Turing x, it came back x equals 9020 and a full stop. That means that's the only answer. Here it says, okay, I found one answer, but there might be more answers. So now I have a choice. If I press return, it just gives me back my prompt. Return means, okay, I only want one answer, I don't need another one. But if I want another one, I press a semicolon, and then it comes back and says, okay, x could also be 9314. So I keep pressing semicolon, it'll keep looking for more answers. Now the interesting with Prolog, I can ask things the other way around. So here Turing was the input and x was the output, but I can say, okay, I could say lectures W, comma 9020. So I'm asking it the other way around. Who's lecturing 9020? And it comes back and says Turing. Now you'll notice something interesting here, like it's offering me the chance for it to go and look for another answer, but when I press the semicolon, it comes back and says false. So you've got to understand, it's just differences in the way Prolog does the search. So sometimes it knows, somehow, when I asked lectures Turing X, it somehow knew that that was the only answer. So that's why it came back with a full stop. This doesn't necessarily mean that there's other answers. It just means it doesn't know. I found one answer, but there may be others. If you want, I can go back and look for them. And when we press the semicolon, it goes back and looks for more answers, but then it actually doesn't find any, so then it says false. Okay? And so this false is a bit confusing. Some versions of Prolog, instead of false, they say no. And no is a bit more intuitive. No just means no, I didn't find anything. So false looks a bit funny in this situation because there was an answer, but that's just the terminology that we have with SWI. Okay. Okay. So any questions about that? Yeah.
What is the difference between W and X?
I can write anything I want that starts with a capital letter, and it'll treat it as a variable. And it doesn't have to be a single letter. It might be more intuitive to say course. What course is COD teaching? And it'll say course equals 9311. Yeah? Now, but notice the capital letter. So if I write this with a small letter, it'll say false. And can anyone tell me what will happen if I write Turing with a capital T? What will happen? Oh. Turing equals Turing. If I say 9021, it'll say Turing equals Smacker. So because of the capital letter, it treats it as a variable. Yeah. Capital letter is always a variable. Yep.
In the file that we load, we always have to use small letters.
That's right. If you're saying facts, it always has to be with small letters. Yeah. Yes?
What happens if you put two variables? So like
two variables. Very good question. So let's say lectures, teacher, course. So that's two variables. It tries to find every combination. So teacher could be Turing and course could be 9020, or it could be COD and 9311. So it keeps finding more and more answers, and if we have multiple variables, it tries to find values for all of those variables. Yeah, very good question. Yeah. Good. Okay, now what else can we do? And we could do the same thing for who's studying what. Studies, student, course. And it'll come back and tell us every combination of which students are studying which course. Right? Okay, so, but now comes the more fun part. Let's suppose I want to ask the question, which students is Turing teaching? Oh, sorry, to exit Prolog you normally press Control D. I don't know if you can read that font, so I'll just put the facts up here. So if I look at this, can someone tell me which student Turing is teaching? Fred. Because Turing is teaching 9020 and Fred is studying 9020. So now we get to these kind of second order queries. So this is how I would ask that question. I want to look for a certain course that Turing is teaching that course, and so because I've written this together, that course must be the same as, because these are the same name, this course has to be the same as that course. And it comes back and says 9020 and student equals Fred, and then there's no more answers. So Turing Turing's standing and Fred's just the only person sitting in the audience. Some other lecturers are a bit busier, like Cod. Cod is teaching Jack, 9311, and Jill and Henry. Okay. So now it's interesting to look at how it does its search. There's a picture here that kind of shows how it does this, and we can make this explicit by typing trace. So if I type trace and then I repeat the same query, you can actually see some information about how it's doing this search. So it's saying, okay, I'm looking for a course that Cod is teaching. So it creates this kind of dummy variable with this funny name, _G387. And then it looks and says, oh, okay, that's a possibility. Cod is teaching 9311. And then it's saying, okay, in order to make all of this true, I must find some student such that studies student 9311. Is that possible? Oh, yes, it could be Jack. And then it tells me that, right? So then I ask it to go back and look again. So first of all, it tries again the same course. Is there some other student studying 9311? I don't know if you can see, but you could see the picture here. It's actually doing a kind of tree. We'll talk a lot more about tree search in week 3. But you can see this, it's saying, okay, 9311 is a course, and I found that Jack studies that. And then it's looking here to see if there's some other students studying 9311, but it doesn't find it. So that's why it says creep. I don't know, this word creep is very weird, but it just means that it's sort of continuing somehow. So it looks and tries to find someone else that's studying 9311 and fails. So because that fails, it goes back, it backtracks and says, okay, well, there's no one else studying 9311, but maybe there's some other course that Cod is teaching. So it looks and it finds 9314, and is there someone studying 9314? Yes, there's Jill. And then if it looks again, it's also Henry. So there's a nice kind of juxtaposition here. This graphically depicts what's being shown here in the trace. Are there any questions about this? Yeah. So this is a, yes? It has to be the same. That's right. It has to be exactly the same. Yeah.
What's the time complexity?
Where does it say? Sorry?
What's the time complexity?
It says the time complexity. Yeah. Oh, of the search. Oh, well, Prolog. Okay, the question was about the time complexity. Generally, just searches kind of naively, and it usually applies the rules in the order that they're written. So it does a search kind of in the logical order. There are other versions of, there are enhancements to Prolog like Mercury that try to speed it up a bit and this kind of thing. But the basic Prolog just goes through like this. And so sometimes, I'll show you an example next week where if you swap the order of two rules, it can actually massively speed up the program, right? So, and then we'll also, sometimes you put in this cut operator. So there are ways to manipulate the search by changing the order of the clauses and if necessary, putting in a cut operator. But if you want to get really fast you have to use a special Prolog compiler and you have to have typed variables, and it's much more complicated. We're not going to get into that in this course. And also, in week 3, I'll show you Prolog code for all the various search algorithms and stuff, so you can play with it yourself. It's not, this SWI Prolog is not super fast. Like I say, if you really want super speed, you got to do these special enhancements with special compilers and stuff. Yep.
What's the meaning of G3898? Appears so many times.
Right, it's just using that as a dummy variable. Yeah, it says I want to find some. I know this looks very sort of old-fashioned, but yeah, it says, okay, I want to look for some variable, and it just has to make up a name. So it makes up a name with an underscore and some random digits. But it has to be the same. What it goes in this slot has to be the same as what goes in that slot. You know, this slot and that slot have to match. Yep.
When it's found Jack, it actually finds it and it exits. But when it's found Joe, why does it exit?
Why does it exit? Oh, why does it exit twice? Ah, sorry. That was my fault. God, you've got good, sharp eyes. This was my fault because I accidentally hit semicolon instead of return. That's why it printed this line. Yeah, that shouldn't be there normally. So we can type these queries, but sometimes they take a long time to type. What we're going to do now is actually put a rule into the file which does this for us. So let's edit this file. Or instead of editing it, I'm just going to do it like a cooking show. This file is the same, but I've added an extra rule at the bottom, right? So those are the facts that we have, and then what I've added here is actually a rule that defines a new predicate. So this defines something that says teachers, teacher, student, if lectures, teacher course, and studies student course. If we wanted to run that query multiple times, we'd get sick of typing it out each time, so this creates a shorthand for us. So if I say teacher student, it actually goes through and tries to do this. Now, which is what we wrote before. Now, I'll just point out a couple of points of syntax with this. So this thing here that's meant to be an arrow, this is if. This is read as if. So teacher, student, if this, and this comma is an and. It's a conjunction. Right, so when we see a comma, that means this must be true and this must be true. So if I do Prolog facts 3a, then it loads those rules, but also loads the facts, but also loads the rules. And now I can do the same query by just saying teachers, say xy, and it comes back with the same answers. Turing is teaching Fred, Cott is teaching Jack, Minsky's teaching Jill, and so on. And if we trace, we can see what's going on behind the scenes, but it's going to be essentially the same kind of thing. So here we've got two of these dummy variables, because we're looking for a teacher and a course, and you see that it's got different numbers, and then it goes through the rules. It says, okay, well, G386 could be Turing, and G469 could be 9020, and then it moves on to the other rules, says, okay, well, is there a student who's studying 9020? Oh, yes, that's Fred, and so on. So this is sort of, it's a bit of a primitive debugging tool, this tracing. So this is what a Prolog program consists of, is a list of facts and a list of rules. And so someone, when we were asking what is intelligence, a couple of people said that intelligence is using existing facts to deduce new facts. That's exactly what's going on here. Okay, any questions about this? Yes?
Are there any cases that the result of the if are false?
The result of the if is false.
It returns if I require the result is false.
Okay, we'll get to this later, but there's a not. You can say not something, and then that means that that has to return false. Yeah, it tries to prove it and it returns false, and then not of that is true. Yeah. Yeah.
With the actual code that you put in the facts file.
Yeah.
Is there a way to do that in the actual Prolog program? Because obviously they look exactly the same as a query and a fact.
Can you define rules on the fly, sort of thing? I don't know whether you can. I'm not sure if there's a way to define rules on the fly, but usually we load it from a file. There are ways to load multiple files. So we'll get to this with the assignment. You can actually load 3 different files and it'll collect all the rules together. Yeah. Yes.
Is there a way to automate the process so it doesn't actually look for user input every time it searches? Is there a way to just automate it so that it always returns with a semicolon?
There is a way to force it when it finds one answer to just stop there and not look for another one.
So is there a way to do the other way?
Which to make it look for new answers.
Yeah.
I'll make it look for all answers. There's a you're jumping ahead, but there's a predicate called find all, and then it'll find all. It'll return a list of all the things that satisfy that query. Yeah. Good. Okay, and so I guess one more point is that notice that it didn't print out the course. So because the course is embedded in the rule, it doesn't tell me the course, it just tells me that Turing is teaching Fred, because that was all that was in the query. So these variables that occur in the rule but not in the query get suppressed and don't get printed. There is a way to put a print statement in and print them out if you really want to know what they are, but normally they get suppressed. Well, I won't go through this in detail, but sometimes if something's true, it might come back with true and then true. This means it can prove this in 2 different ways. So in this case, we want to ask whether Fido is a bad dog. So we've actually just given that as a fact. Bad dog Fido. So that's one way it can prove this, is just using it as a fact. But it can also prove this in a different way by saying that Fido bites the postman, and Fido is a dog, and the postman is a person, and if a dog bites a person, then it's a bad dog. So you can go through this complicated reasoning. So it's sort of, from a point of view of logic, this is kind of weird, like something's either true or it isn't, like it can't be doubly true. But in Prolog, this is saying, oh, not only is it true, but I can prove to you in 2 different ways that it's true, right? So sometimes you get this funny kind of double answer.